Assalamualaikum. Morning. Boleh dengar?
Assalamualaikum, Prof.
Okay, we are doing revisions. Last year exam questions. Okay. Which 10 of July, 2021. So your final exam will be on the 12th of July, 2022. Okay. So we go for question 1, is answer all questions. Okay. 4 questions, answer all. So we try to finish 1 and 2 by today. Liana, if you don't mind, can you read for me? Hello, Liana.
Yes, Prof.
Can you read for me?
Okay. Question 1A, a unity feedback control system is given in figure Q1A. Determine the following. 1, breakaway point of the root locus at real axis. 2, angle of arrival at complex zeros. 3, intersection of the root locus with the imaginary axis. 4, then sketch the root locus based on 1, 2, 3. B, the control system in figure Q1B has an open loop transfer function of GS 1 over S plus 3 times S plus 5 times S plus 8. The system root locus is given in figure Q1C. At K equal to 100, the closed loop poles are S12 negative 2.77 plus minus J 3.65 and S3 equal to negative 10.4. Simulation result of the system when applied with a unit step input is shown in figure Q1D. By adjusting the value of the proportional controller K, the system could give a close approximation to a second order system. Design the proportional controller K such that the system can be approximated as a second order system. Justify the validation of second order approximation.
Thank you. Okay, so straight away we go to the solutions. So the question asks you to, on the breakaway point. So breakaway point.
Oh, paper dia.
Apa pula dia cakap. Oh, Mike. Zarif, oh, Mike. Breakaway point. Okay. Kita ambil dia punya equation 1 plus k s square plus 8s plus 32 s minus 1 s plus 3 equal to 0. Okay, and then this one you simplify, you will get okay, find dk per ds. Okay. Then equal to 0. So you will get 12s squared. So calculator please. Ahmad Najwan. Calculator please. Datang.
Ada doktor.
Hei. Mau bengingnya lah.
Saya baru masuk.
Baru masuk. Okay. So macam inilah dia punya tu. Okay. Angle of arrival of complex zeros. Okay. Idea please. Angle of arrival.
No idea.
Huh? Kan? Satu. This one is theta 1. Okay. Okay. Idea. Theta 1, theta 2 due to zeros. Theta 3, theta 4 due to poles. Datang. Okay.
Ada Prof.
Oh, tak punya budak ni. Kau ada test ke malam ni?
Ada.
Tak ada.
Ada.
Oh, patutlah tak fokus. Alah, aku tolong. Okay. So, theta 1 will be 21.6 degrees. Nanti kira balik. Okay. Guna inverse tangent and so on. Then intersection the roller curves with the imaginary axis. Tengok pakai apa? Tika. Pakai apa Tika?
Sekejap. Apa dia?
Use what?
Use. Characteristic equation.
Characteristic equation. Okay. So you permudahkan, so you akan dapat 1 plus K. Okay. So what next? After this, Shahin, what next? Shahin,
Yes,
Tarata.
Prof.
What next?
Vegetable.
Apa benda tu?
Ah,
Apa tu?
the Prof Howis.
Prof Hawis.
Yes.
Prof Hawis. So kan? Ni kan? Okay. Kalau kita simplify, kita dapat apa? Tiga tambah 32K. Okay. So sekarang ni we have first column. We have this. Okay. Okay. So first column tadi berapa? 1 plus K greater than 0. Okay. Then next, minus 4 plus 8K. K is equal to greater than setengah. But if K is equal to half, so you will get will become row of zeros. Okay, so therefore kita ambil equations. Okay, find PS auxiliary equations, which is 1 plus K S square plus 3 plus 32K, okay, equal to 0. Simplified, so you can go to zeros, which is PS. Okay. So PS is equal to 3 over 2 S square plus 19, which is equal to 0. So simplify, so you will get plus minus J 3.6, okay, which is located over here. Okay. Then sketch the locus on 1, 2, and 3. Okay, already sketched. Next question is okay, Q1C. Okay, plot is given. All root locus ended at infinity. open loop transfer functions. K equal to 100 minus 277. Okay. Then simulation steps Q1D, which is this one. Okay. So it looks like second order approximations, even though the open loop transfer function is third order. Okay, this one third order, but the behavior of the system is a second order, meaning that it is a second order approximations where third pole can be ignored. So the ratio minus 10.6 minus 2.77 magnitude. Berapa ratio ni? Ivin Tan?
Yes, doctor.
The ratio 10.46 divided by 2.7.
3.78. 3.78.
3.78. Meaning that this one is purely third order because we cannot ignore the third pole. So by adjusting the key, okay, the system could give a close approximation to second order system. Okay, originally is a third order pure. Design P controller so that we can get the second order approximation, justify the validation. So this question actually is a open-ended question. Okay. And then you should pick up the correct dominant poles. Okay. Location such that the ratio is greater than 5. The one that we have now is like Ivin said just now, the ratio is 3.78. Okay, so this dominant pole is and third pole is become original third pole. Your task is to change the K 100 so that the system become second order approximation where the ratio will be greater than 5. Do you understand what I'm trying to say? Mukri, do you understand what I'm trying to say?
Not really.
Not really. Not really. So you pick up location on the rule locus that will give the damn response. Number 2, this step lah. Because they open the question, I give you guidance on how to do it. Okay. If you want to follow, okay. If you don't want to follow, also no problem. Then calculate the value of K. Okay, and then find the respective third pole locations. Then number 4, respective ratio to validate the second order approximations. Of dominant pool. Sorry, sini. Number 1. Number 2, calculate the value. Okay. Then find the respective third pole locations. And then validate the respective ratio, mass greater than 5. So give me one dominant pole. Any value. Simichin.
Yes, Doctor.
Based on your understanding after 15-week class, okay. So next week will be the last week. Give me an idea. Give me the dominant pole's value that will change the system from third order to second order approximations.
So
Any value. What is the value you like?
27.
27. That's too
Yeah.
high. That's too high. Banyak sangat. Banyak.
17 lah. 17.
17. Too big.
Yeah.
Tengok ni scaling dia.
Okay,
Scaling dia. Why kalau dia kita ambil
Penting lah.
-1 plus 7. Okay, try -1 plus 7. 7 di sini. Okay. This is the propose. I propose now. Simichin lah propose. By Simichin. Okay. Which is -1 plus 7 lah. As the dominant pole. Okay. So you nak choose -1 plus 6 point okay. Okay. Try. This is open-ended because last year kan is the MCO, PKP final exam online. So one way to avoid student copy each other is by designing the open-ended question. Okay. So K, ES, HS, that's the one. K, S plus 3, S plus 5, S plus 8. Okay. So what is the value of K? K will be 580. Smile. How I get K 580?
Yes, Doctor.
How I get K 580?
Magnitude criteria.
Like this.
Okay.
Like this.
Yep.
Okay, so replace with S minus 1 plus J7. So inside 580. So the third pole, how to calculate the third pole? Benjin.
Yes,
How to calculate the third pole?
Huh?
How to calculate the third pole?
Oh, sub the K inside the characteristic equation and then get the S.
Can you which equations?
The characteristic equation.
Okay,
Yeah.
Mana boleh lah. Tak boleh lah. Simichin, how you calculate third pole? Ada dalam notes tu.
Same idea with one thing.
The idea
Characteristic equation equals to 0 and we find the pole.
0, then insert s plus 1 minus 7, s plus 1 plus j7, then s plus third pole, TP, then k is equal to 580. So you use calculator, then you will get third pole is equal to minus 13.94. Okay. So the ratio is now, what is the ratio now? Third pole minus 13.94. Dominant pole that proposed by the students minus 1 plus J7. So what is the ratio? Don't help me. Don't help me. Datang. Greater than 0. So second order is one. Okay. So the one that we choose just now is minus 1 plus minus J7 K 580. This is the one that we choose sekali saja, then we give the answers. So note any answer for K from K is equal to 190, where dominant pole is minus 2.26 plus J 4.68 and third pole minus 11.47 will do, will satisfy the second order approximation. Okay, this is the minimum one. Okay, if you look here, the ratio is minus 11.47 divided by minus 2.26. Berapa? Chung Hui Ki. Chung tak datang. Okay. Leong? Miss Leong? Tak datang. Chua? Chua Leong? Tak datang. Okay, which is greater than 5. This is the minimum one. Okay. Second question. Fikri,
Ya, Doktor.
sila baca.
Given a start response for a unity feedback system for an uncompensated system of G uncompensated S equal to the function and the compensated system G compensated system. G compensated S in figure question Q.2a, the transient response for the system which utilize a PD controller yield a faster settling time TSN than that of the uncompensated system TS, given that the damping ratio for the system is zeta is 0.456. Referring to the figure Q.2a, if the damping ratio zeta equal to 0.456, determine the dominant poles of the corresponding uncompensated system. Based on A1, determine the dominant poles of the corresponding compensated system. Using a PD controller algorithm, determine the transfer function of the overall uncompensated system G compensated S. For Roman, the system is further improved by combining the PD compensated system in 3 Roman with a PI controller with a transfer function GPIS equal to the function using the final value theorem. Show the comparison of the steady state error of the uncompensated system, the proportional derivative compensated system found in 3 Roman, and the proportional integral derivative controller overall uncompensated system. Assume a step input is used.
Macam Fikri,
Yeah, you're off.
baca jawab belum lagi.
You're off.
Okey, tengok ni. Kira dia punya apa? Zeta 0.456. What do we get from the graph? Apa yang kita dapat dari graph? Dia rule locus tak bagi, dia just bagi open loop transfer function. Zeta 0.56. Okay, ni berapa ni? Theta dia ni. Perlu theta ke? Tak perlu. Ni. You have to read from the graph. Uncompensated system. Lebih kurang sini, settling time ni. Okay. That is the settling time for the uncompensated system. Okay, 1.8. From the blue graph, settling time is 1.81 second. But settling time is 4 divided by real, okay, which is equal to 4 divided by 1.81, 2.21. Okay, so it's lower. Okay? So this real, okay, zeta omega n is equal to 2.1, which is the real part. Okay, so omega n is equal to 2.21 divided by zeta. Berapa? Irfan, 2.21 divided by zeta.
Jangan tengah kira. Tu.
Okay.
Laju dia. Betul.
Saya anggaran. This is 0.456. Imaginary part. How to calculate imaginary part? Result. Omar. Syekh Omar. Absent. Afifi. UK Wong. Imaginary. Okay. 4.85. 1 minus. Berapa ni?
4.316, 4.32.
4.32. So the dominant pole will be okay. Then find the apa soalannya? Okay, sudah. Based on A1, determine the dominant poles of the corresponding compensated system. Jadi yang compensated system itu berapa? Ini yang lama, settling time yang baru. Continuing, new settling time, the red one.
.9.
0.9 macam sikit sangat. Dia dah lepas satu ni. Nampak tak? 1.21. 1, 2, 3, 4. 0.2 bagi 4. 0.2 bagi 4. .01. Almost here. Okay. Agree? Con, agree. Disagree. Disagree. Okay. So again, you repeat again the real part. With the new 1.01. Okay. And then the this one is zeta 3.96. But the zeta is not changing. 0.456. Okay. Imaginary part. Irfan, imaginary part.
Oh dia satu boleh tidak.
Hmm. Okay, so this one is the imaginary part. So the new dominant pole after compensations is 7.7. Okay, so using a PID controller design, determine the transfer function of the overall. Okay, so we design PID. Okay. So how are we going to design PID? Chong Juan?
Yes, Doctor.
PID mah. PID pula, PD. Plus. Dah sampai. Dah siap. Okay. Bahaya. Sekejap. Masa PKP dia trip down, tak boleh ganti. Berapa? Bersihkan dulu. Bersihkan pun tak boleh. Bersihkan pun tak boleh. Nanti saya suruh dia pergi jumpa you lah. Okay. PD controller using seven three. So you plot lah dia punya tu. Okay. Plot. So -1, -5, -15. And the dominant pole is somewhere here. Okay. Okay, so this is theta1. The 3. Okay. So kena kira sudutnya. Okay, so theta 1 is 111 degree, theta 2, 82 degrees, theta 3, 4 degrees. And don't forget to put the ZC somewhere here for the PD controller. Okay. Ya, ini bukan pole, ini patutnya ada zeros. Nah. Right, so di situ kalau kita kira ZC-nya is equal to summations of theta 1, theta 3 minus 180 degrees. So tangent 48 degrees go to 7.73. Okay, by drawing the A is equal to 10.9. So overall, G and GC together, so it will be 72.8. The gain S plus 11.4 S plus 10.9 S plus 1 but the K, this is the previous K. So kalau kita gunakan the new K, so it will be $10.9. So we'll get 83.8 replacing the S with minus 3.96 plus J 7.73. So overall, okay. And then finally is the PI controller. So this one is given, you just use it. Okay, multiply sahaja the PI controller. So it will increase the system type from 0 to 1. Okay. So the KP is S to 0. 11.84. So that is the value. Is it correct? 1/12.84, 0.278. Please check. Correct?
Doctor, I get 0.077.
So for KPID, okay. So kalau kita find for type 1, KP is equal to infinity. Zero. So we stop here. Continue next Wednesday. Okay. Not.
Okay, Prof.
Okay, guys, we stop here because you all have exams today. Everybody is busy. So see you next week. Submit your assignments by Friday. Okay. Thank you very much.
Thank you, Prof.
Take it, Prof.